So this is gold.
So have y'all had enough time to review the effective math teaching practices? All right, so we're gonna watch a video in a couple minutes from Miss Rossman, who's a 6th grade math teacher. So she's gonna be working through the hexagon task. So just a little bit of background on this class. Many of the students have recently come to the United States, so you actually have a lot of English language learners. They're in a dual language program. And this is the first task in a unit about number sense, patterns, and algebraic thinking. Specifically, she had 3 math learning goals. Now I mentioned she's a 6th grade teacher. So if you're using this task for 5th grade or 4th grade, you would not have all 3 of these goals. For her goals, she wants students to create a generalization that describes the relationship between the train number and the perimeter, and explain how the components of the generalization can be seen in the pattern, which is something as you're working I kind of prompted you. Where did the 4 come from, for example? She wants students to be able to identify that constant rate of change between those quantities. As the train increases by 1, the train's perimeter increases by 4, and thinking about that as a constant rate of change. And then part 3 is not something you're going to do with elementary kids, but it is something appropriate for 6th grade. And that's understanding the rate of change as the quantities can be seen in a table as the first difference, in a graph as the slope of the line, and in an equation as the coefficient of the input quantity. So they're starting to get at this idea of slope and rate of change, which is where students are headed.
Gosh, I don't understand that.
But they could still do this task for you guys for an earlier grade. You just have to think about the appropriateness of your learning goals. Okay? Are we good?
Yes, ma'am.
All right, so a little bit more. Prior to this clip, Ms. Rossman has launched the task. Just like we do with Polya's phases of problem solving, she's made sure that students understand what's being asked of them, and she's communicated that all the students in the group should understand what they're doing and be able to explain it. So in this clip, we'll first zoom in to a small group, and they're working on their explanation, interacting with the teacher, and then we'll see part of the whole class instruction. So your lens for watching the video. As you watch the video, be sure you make note of what the teacher's doing to support learning and keep students engaged. And in particular, I mentioned that you have the 8 effective math practices. You also have a transcript, which you can certainly refer to, especially if you have difficulty hearing any parts of the video. But then I'll give you a couple minutes after we watch the video as well, if you need to write on the transcript at that point. So if you just want to watch the video the first time at face value, you can, and then you'll go back and you'll be able to refer back to that. The nice thing about the transcript is that there are line numbers. So when we talk about where we saw certain things, we can all be on the same page. So be prepared to give specific examples and line numbers from the transcript to support your claims about how Ms. Rossman engaged in those math teaching practices. So what questions do you have about your expectations while you watch the video?
No.
Okay. Are we good? I love jumping into the classes. It's fun. Jump. Yeah. Jump. All right. So let me switch over. About 5 minutes long.
22 plus 26 plus 4 is 26, 26 plus 4 is 30, 30 plus 4 is 34, 34 plus 4 is 38, and 38 plus 4 is 42.
Okay, so you're telling me you saw a pattern here in the numbers?
Yeah.
How could you find the perimeter of the 10th train if you didn't have this information? Would there be another way to find the perimeter of the train? Like you're telling me that this perimeter is 4 more than this one. What's another way to find the perimeter if you don't know this?
We start with 1 and we know that's 6, and then we put 2 and with a line, and then we think that in a corner we can get it.
Why do you think it you add 4 from the picture?
Because right here we count in 6 and then we count like this all the way and then he saw the count by 4 and get all the answers.
I'm wondering where this thing that you're talking about, the 4 all the time, where is the 4 in the picture?
1, 2, 3, 4.
Like this is 4 more than this one, right? But where in the picture is it 4 more than this one?
What do you mean?
In the middle. What do you see?
Oh yeah, because right here when that is right here is 5 and right here is 4. 5 and then because we have to put in another one right here and this one is got to be 1, 2, 3, 4.
Ah. What do you think?
Yeah, he's right.
What does he mean? Where's the 4 in the picture?
Yeah, because if we cut with
How much is on this one? On the end?
5.
How much on this one?
5.
How much here?
4.
So how could you think about that for the 10th one? Can you imagine in your mind what it looks like?
Yeah, 5.
The first and the last one is going to be
5. Oh yeah.
and the other one is going to be 4.
Well, I think you should write about that, because that's what it says to do here. Without building the 10th train, write about how you find that perimeter. Can you write that?
Yes.
Okay, good. Go ahead. What did you do?
The 2 we did the first 2 we're gonna be 5 because it's just 1 because the first and the last one is 5 because there are just 1 with the first and the last one and the other ones has 2 and then we're gonna be 4.
Okay. Can you come on up here? I wanna post this on the board, and maybe you can come and point what you're talking about.
I'm talking about those 2 numbers because those has 5 and the other one just has 4 in each one. The number every number who is it?
Okay. So where did Daniel say he was getting a 5 from?
The first one and the last one.
Can you come point to the 5s? Come on, point to where the 5s are. You can stay here for a second, Daniel. Okay. Show me where the 5 is in the first one. Can you? 1, 2, 3, 4, 5. Okay. And show me where the 5 is in the last one. Do you understand what he's saying?
Yes.
Which train is this? 10.
Yeah, he said that here in the middle on the exit that has 4 sides and the side yeah, right here and right here. There's the exit and the pass.
Ah. So how many of the hexagons have 5 side lengths?
5.
And then how many of the hexagons have the 4? Ah.
Because there's 10 exits.
Okay, so does Miguel have your idea pretty good?
Yes.
Okay, good.
All right. So, as promised, I'm going to give you a few minutes to go through the transcript and make notes and connections to the 8 practices. But are there any reactions that you have in general before you do that?
They took a totally different approach than we did.
Okay.
By looking at like how many sides each shape has and then the endings of the train. I don't know. I thought it was interesting the way they did that.
It was interesting the way he talked about the 5 on each end. Okay. Any other observations? Okay, so take a few minutes and build the rest of those connections between the 2. You're welcome to them. You can have them.
I didn't know if you were using them for
I'm not. They're not a mathematical tool. They're simply there in case you need chocolate. Yes, please help yourself. And likewise, please help yourself to some granola bars. So, you could even take a few if you'd like.
Are we going?
Hmm?
Are we going?
We are going, okay. So let's, we have our transcripts, we have our connections. So, since our group is small, what are some of the connections you made specifically from here to here? And be sure you refer to the line numbers so you can see.
Well, I noticed a lot of purposeful questioning, and that happened like all over the place. So I'm not gonna like first off, line 3, that was a great question, and then the entire like line 5, that whole thing there. And then you have some more questions like throughout. She just asked a lot of questions to like scaffold them into the direction she needed them to go. And then that also supported like the productive struggle, because she has them thinking about like why things were happening and what they were noticing.
Absolutely, and I would dare say that these weren't all questions she thought of on the fly.
Oh yeah, I know. She was just like, what can I ask them to get them to think more deeply about this?
So one of the pieces of feedback I've given a lot of lesson plans is plan for the questions, ask those purposeful questions. And even though to the kids, it may sound like Ms. Rossman is coming up with these questions just off the top of her head, clearly these were very thoughtful questions.
I thought the whole lesson was productive struggle.
Yeah.
Like, because she like walked the students through the process, but she never came out and directly told them how to do it. And like Sierra said, I think she did this through lots of purposeful questions. And a question that I really thought, like there were lots of purposeful questions, but one that I really liked that she asked was on line 16. It says, I'm wondering where this thing that you're talking about, the for all the time, where's the for this picture? So she was like using the words that the student used to make her question. Like, I think that has to be kind of like good for the student to hear their own words being spoken back to them, and kind of gives them more confidence to solve the problem, because the teacher's like on their side or whatever to solve this. So I just thought that was really great.
Yeah, that was, I mean, and she's definitely asking for this clarity piece here, and the connections between the representations are embedded within her purposeful questions.
And then they were kind of like analyzing approaches, like towards the end when they were looking at another student's work to like see what that student was doing, and that was page 3, like 61, 62, and then 68, all right there. They were analyzing other students' work to see like how that student actually answer.
Yeah.
Yeah, I commented on that part too, 64 through 69.
Yeah.
I said that was like use of student thinking, because she called the student up to the board to describe their thinking and like to come up and like show how they got through that problem together. And so I commented on that too.
Absolutely. And these are teaching practices, and so y'all are absolutely accurate on that. But we also know, another comment I've put on a lot of the lesson plans is be sure you're integrating the standards for mathematical practice. So aligning standard for mathematical practice would be that they're constructing viable arguments and critiquing the reasoning of others. So the teachers certainly are listening and using evidence of student thinking. The students are thinking about the reasoning of their peers too. So that's a really cool connection.
And didn't see any like progress monitoring. Well, the last one of the 8 strategies or practices, but I'm sure she's doing that just like on her own outside of the video. And then I didn't see any like clear goals, but I'm sure she set a goal before the lesson.
Yeah, but and also you kind of showed us those goals beforehand, so I kind of just like assumed she told like the students that beforehand, or like she has them posted somewhere in her classroom or something like that.
Or at least have those at the forefront of planning the lesson.
Yes.
Yeah. And I saw like a lot, I don't know if I said this, but a lot of like reasoning, like she had the kids like reasoning a lot, and trying to figure out like, well she pretty much had the kids thinking about their thinking, which metacognition.
Metacognition, yes.
And she did that by reasoning and just getting them to really think about what they were doing.
Have you guys been studying that in another class?
We've learned, we did it a lot. It's just something that I remember.
That's awesome. I knew you were applying something because we haven't really talked about metacognition
Yeah.
in this class.
We learned about it a little bit last year, and then we talked about it a few times in Dr. Rivers. It just pops up in random little places.
Once you know the tool, then you recognize it, right?
Yes.
I think this was very, and this kind of goes back to the productive struggle comment I made, but I just really liked how like it was very student based. Like the teacher really didn't have her hand. I mean, yes, the teacher was there and she was walking them through the steps they needed to do, but it was very student based, and the students were working together as like team members rather than like working independently for their own cause. They were working together as like for a group cause, and I kind of really like that approach.
The teacher was very much the facilitator.
Yes,
She was still in control, but the students were leading the discussion.
Yes, and it's awesome that it was a discussion about math, and they were that like intense. So I love that even better.
Absolutely.
I'm sorry, I keep going. I'm just thinking to myself. I feel like it's easy to have discussions about books and English concepts and those kinds of things, but I feel like math discussions can kind of be hard to have for students because it's like kind of like a, you know, like you kind of have to wrap your mind around it first before you can discuss it. And so like how they were able to discuss this so thoroughly, I just think that's really great.
So I don't entirely disagree with you, but I would offer that there are just as many opportunities with math, but a lot of people feel very vulnerable in that space. And so when I look at Miss Rossman's class, it looks to me like she's done a great job of creating a safe place. I mean, we look at these students, and some of these students, English is not their first language. There's a vulnerability already, and now they're being asked to speak about their mathematical thoughts on the first day of a unit. So she's definitely done a good job of creating a safe environment.
Yes.
Whereas sometimes, perhaps in other subjects, that complexity of creating that safe space might come a little more quickly, or maybe the teachers feel like it does. I'm not sure, but I do know that that safe space was an important component in that discussion happening. So
I just know from my own experience with math, like we never had discussions like that.
so many missed opportunities.
It was just like teacher teaching and I doing notes and examples.
Well, you can come to my office. We can talk about math anytime if you need to catch up.
Yes. Okay. No, it's like that's just why like I think it was so awesome because like I've never experienced that to that extent, you know, and so I just was kind of like blown away by that. So
Yeah. Thank you. That's awesome. All right, so you guys have done a great job of going over a lot of the highlights from how Ms. Rossman engaged in the math teaching practices. I think it's nice to kind of come full circle too in the school year. Like we started out, we said these are 8 math teaching practices we're going to try to model and we're going to see in different ways. So I thought it would be nice to bring that back. So we're not done with this task though. Specifically, you guys talked about productive struggle, so I did want to highlight this. This is the description of productive struggle from principles to actions. But I want to highlight this quote. So by struggling with important mathematics, we mean the opposite of simply presenting information for students to memorize or being asked only to practice what's been demonstrated. So too often, math class has been just this, just the memorization or asking you to do something that I've demonstrated.
that's my experience, yes.
And that's restating exactly what you just said.
Yes.
So instead, we're going to try to strive for this productive struggle space.
Did you know we were going to discuss productive struggle? Like you just like anticipated that and that's how you had a slide?
I did anticipate that, so I'm glad it worked out. So productive struggle was the effective math teaching practice that I wanted to be sure that we highlighted. And I think from the video, that was a pretty good bet.
You read my mind.
I tried, but it doesn't always work out, but sounds like it did. Okay, so the next piece I want us to do is to look at those 3 pieces of student work in your folder. So I'm going to give you some time you can certainly communicate with one another. I'd like for you to review the student work. Did you anticipate any of these solutions? And then it would be great if you all could discuss, if you two could discuss, what did the student appear to know from the work? What are you not sure the student understands? And then specifically write down, so these first two should just guide your conversation. And then write down what are questions you could ask to make their thinking clear, and to move them toward reaching the goals of the lesson. So we talked about the goals of the lesson at the beginning. So what are some questions you could think to keep them advancing toward those goals? Okay, so you have 3 pieces of student work. So you'll need a few questions for each of those students.
Okay.
Okay, so I'll set us a timer for about 15 minutes, which will give you about 5 minutes to consider each of the students. And you can certainly take a working break in that time as well. So if you need to stand up, stretch your legs, take a restroom break, feel free.
Okay.
So student B.
They did like the same one we did.
Yeah, they really did.
It increases by 4 each time. You can keep and justify the
Yeah, so you want to be sure that you answered, as y'all talk through it, what does the student appear to know? And then what are the questions that you could ask to help make their thinking clear or to help them move toward the goals of the lesson?
Okay. So, are you ready?
Yeah.
Okay. So we feel like the student really had a very good grasp on the whole like idea of this hexagon task, and so they thought of it as counting how many people could sit at a hexagon-shaped table.
Yeah.
And so would you like to share one of
Yeah,
our questions
so
we
they-
came up with?
Well, they figured out that 2 of the sides don't matter. Well, they matter, but we don't count those because they're shared sides. And then they created this table, and one of the questions we had for this table, since they didn't really show us how they got all of these numbers, was what process did you take to get the numbers in the Y column, to make that more clear for us. And then our other question.
And then our other question was kind of like, how can you check to see if this equation would work?
Yeah.
And so the way they would do that is you would plug in one of your numbers for X and plug in one of your numbers for Y.
And
then
substitute.
just solve it. Yeah, substitute.
Yeah, just see if it's.
Substitute and see if it works. So for example, if I was this student, I would say, well, I'll substitute 1 for X, and then substitute 6 for Y, and so then 4 times 1 is 4, and then 4 plus 2 is 6, and so then Y is 6, and so I know that equation works for this
Yeah,
one.
And that takes us back to that balancing of equation because both sides equal 6.
And so, and it does work for the rest of these as well, but we would just want the student to kind of explain how they got to this answer, especially since they seem to have a very rounded grasp on this task.
Yeah.
So just kind of explain their thinking and how they got their answer.
Awesome. Well, thank you. So I suspected we might have like one set of questions because of our class size. So I do have a set of questions for us to consider for each of these as well. So a good question to always ask, even a group that's done it right. I heard you all talking about what should we do for the group that's done it right, is can you tell me what you did?
Yeah.
Because sometimes those kids need practice. All kids need practice explaining their thoughts. So that's always a good one. And then what do you mean by 2 spare sides? And what do you mean by each side has 4 sides to spare? And why doesn't your rule work for 0? And then how do these different representations connect to one another? So those are just some things. I think you guys had discussions along those lines, but
Yeah, we did.
We just
How
didn't
were
come up with-
talking about the
We
ways
just
after
come with
that's the
questions, yeah.
yeah. All right, student B.
So this student pretty much did the same strategy, me and Star were using, except they didn't show really any other processes on here. They just kind of gave us the answers. So first off, like, how did you get 42? For
Should
the
work.
yeah. So yeah, how did you get the 42? Just like what was your process in showing us that, because they didn't give any computation on here whatsoever really.
And then since they didn't really do that, because like they just kind of like because they didn't show work, we're assuming that they guessed to get 10. And so then we are asking them, well, what would your process be for finding the perimeter for the 50th train? So then we're giving them a bigger number they have to work with, so then they have to use some kind of work to solve it, because if they have 50 such a bigger number than 10, that then they can't really just guess and check. You know, you kind of have to have a process to work through it. So that's why we picked a big number like 50 to do for this one.
And to get them like towards the goal of the lesson, I feel like this would give them more practice in trying to find, like, see that algebraic part of it, and giving them more practice with that, actually seeing what they're doing and seeing what they can do to get to the 50th train. Since they, I mean, I don't know if it's, I think it's right for answers, yeah. So, that's all we have for that one.
Yeah.
Awesome. But you guys came out with that sort of extension to push them
Yes.
to the
just a-
generalization, because
yeah.
they're counting or something, yeah.
Yes.
And eventually you're not gonna have enough hexagons.
Yeah, so you can't always just do it that way.
Awesome. Thank you. So, yeah, I mean, I'd added in some clarification here. What does the +4 mean at the top? Even though that's, you know what that means.
Weird.
I thought this one was the one that said +4. It increases by 4. Oh, I was thinking, yeah. Maybe I wrote the notes for the wrong one. I was thinking it had +4 at the top, but this one doesn't. This one just has the other. Okay. So where is the +4 in the picture? So maybe I had that a little backwards. And then can you predict the number of 4s you're adding? So I may have flipped those over. Huh, okay. From over there, I was thinking it was the one with +4, and then I was good. All right. Maybe there was a different one that had +4 at the top. I don't think. All right, student C.
So this student was counting the shared sides.
In part of the perimeter.
Yeah, so our first question was like, what is perimeter? Because maybe they don't have a clear understanding of what that is, and just getting them towards like, would that shared side count in the perimeter? Like, would we count that?
I feel like, just real quick, what we mean by shared side,
Yeah, are the sides that are connected within the pieces.
that's what we mean by
So
shared side.
they're technically not a part of the perimeter because they're not on the outside of the shape, they're on the inside of it.
We're part of the area.
Sorry.
No, you're fine.
Okay, and so after we would talk about what perimeter is, we would then lead them into like thinking, would the shared side be considered in the perimeter? So like, after they've talked about what perimeter is, then we want them to think about this shape and to think about, well, what is the actual perimeter of this shape, and would the shared side be included in this perimeter? And obviously the answer is no, but we want them to get to that realization themselves.
And they kind of got an idea of what we're doing because they made a table. Their counting is just off because they did count those shared sides. So our next question was like, what would the equation look like here? Because we didn't see an equation on this one. So
They
just
talk
didn't-
about 6x down here, but
Yeah,
like we
they
really
talk
didn't
about it,
see
and
An
like,
expression. of
Yeah,
it.
they
yes.
didn't express it. So we wanted to know like, how would you take that explanation, turn it into the expression for the equation that you got?
And this is probably the biggest, like the most common erroneous strategy that you'll see. Because I know hexagons have 6 sides, we have 6 hexagons, we should be 6 times 6, right? So this is certainly one that you should be prepared to respond to when you pose this problem, because you're going to anticipate that's going to happen.
yes.
All right, so you could ask, I just put these in here, but just guiding through. So I think you guys did a good job of trying to get them to understand where their misconception is. All right, thank you.
Thank you. Good job, Sierra.
Good job, everybody. All right, maybe my camera won't turn over. All right, so a few things to think about. I have, I want to focus on these questions for just a minute as we wrap up. So we are almost done, sadly. This has been such a good problem. But before we do, I don't want to forget about this question that Sierra mentioned at the beginning. So now that you've grappled with the problem yourself, you've watched a video of children working on the problem in a classroom, and you've looked at 3 different students' work aside from the classroom video. Let's revisit this idea. For the question 4 on your sheet, could you use the fact that the train 5 has a perimeter of 22 units, and then divide 110 by 22 or by 5? Does that make sense?
I think that me starting with knowing that that train 5 has 22 units does make sense, but as far as dividing the 110 by 22, I'm still not sure about that. I don't know.
Still not sure?
Okay. I don't know, I might be totally off here, but can we set up a proportion to solve this? Do you know?
So is the relationship proportional?
Because what I was thinking was, what if we put 100, like, we put the number of sides together, so, or the perimeters together, so like 22 over 110, and then on the other side we do the train number, so then we would do 5 over x.
So you're saying 22 over 110?
Yeah, equals 5 over x. And then could you cross multiply and solve it that way?
So explain to me why you want to do this.
Well, because 22 and 110 are both the perimeter, and we know the perimeter of train 5 is 22, and we know the perimeter is 110, but we just don't know what train number it is.
Oh, so you're trying to see if they're proportional to one another.
Yes.
Okay, so let me ask you a question before we do all of this. Would it work from, say, train 2 to train 4? Because you guys found train 2 and found train 4. So what would that look like for smaller numbers?
Okay, that would be 10 over 18, and then 2 over 4.
So I'm asking this because these are some that you've confirmed. Okay?
Mhm.
So does it work?
No,
No.
Why not?
because of the equal sign.
Yeah. Because you do 10 times 40 is
It's 40 and then 18, yeah.
So let's think about the train though. Okay, so my little trains are probably gonna look a little sad.
Okay, so do mine.
Okay, so is that our 4 train?
Yeah.
Okay, so for our train number 4, what's staying the same and what's changing?
The only thing changing is the end.
The end?
Well, for train 4, what's staying the same and what's changing? The entire train's gonna stay the same except when you add that extra piece to it. Is that what you're asking?
So you're thinking about we're adding
Yeah.
over here, we're adding 4, a net of 4 more.
Yeah, and then the end is gonna become a shared side when you add that extra piece, but that's not gonna change because we're not touching the rest of it. We're not taking anything away.
Okay. Or the student in the video talked about your 5s. Do you remember that?
Yeah.
So you had your 5, like sort of your end caps of 5,
Yeah.
and then all of the others contributed 4.
Yeah. Oh,
So why does it not work as a proportional relationship?
because it's growing. It's gonna grow.
Because it's not growing proportionally to the number,
Yeah.
to the train number.
Yeah.
Because you've got these constant pieces. You see those constant pieces, whether you look at it as trains adding this way or as things that are growing from the middle out, you've still got those constant pieces that are making it such that it's not just a proportional relationship. So one good strategy is to think about, did my smaller case work? And that was a smaller case we could confirm. But I thought it was a good question to bring up because this strategy does work for things that are proportional. So it's like something you just have to know when you can apply it. So it's a good conversation to have. So I'm really glad that you brought that up and that we can come back and kind of hash that out. Yay, good job.
So wait, what number train is it?
Oh, so here's a good question. So if the perimeter is 110, what train is it?
Let's go back to like kids' equation.
Oh yeah.
The one from the video?
4x plus 2 equals y.
Oh, plus 2 equals y.
4x plus 2.
4x plus 2 equals y.
So our
Okay.
y is going to be 110, right?
Yes, because that's the perimeter. And then you solve for x.
Yeah.
So that would be 108 equals 4x.
Divided by 4.
I don't know if that is off the top of my head.
Is it even gonna go?
Yes, 27.
27th train.
So the 27th train.
Wait! I swear I said the 27th train earlier when we were solving this. I swear I did. Star, I swear I did.
Did
gotta be
I don't
honest.
remember.
Because I was dividing, like my strategy, okay, I wasn't thinking proportionally whenever I was trying to solve that. I was thinking of like, how can we get that, like how can we divide that 110 up by that 22 to see how many trains it was? Well, yes, that's what I was thinking. Because we knew we knew that the 5th train was 22. So if we did like another 5 trains and another 5 trains and another 5 trains until we got to 110. And then we knew that each 5 train had 22 sides and we multiplied that by however many 5 trains are 110. Does that make sense? That's what I was thinking. I wasn't thinking of that.
Gotcha.
Yeah.
Oh. I need you to say that one more time.
Oh God.
That's it. I know that's it.
Are you recording right
Yeah,
now? I
yeah.
don't want to. Okay.
Yeah, but
So
I'm really trying to grasp, and I wanted to draw this too for another reason. So tell me one more time.
so we know that a train of 5 has 22 units.
Yes.
So we want to find. What's the question again? I keep forgetting what the question is. Okay. So we want to know what train has perimeter of 110.
Mm-hmm.
So we find how many trains of 5 fit into 110.
Uh-huh.
We could multiply each of those trains. We can add. Okay. I'm forgetting what I said. Maybe can I draw on the board maybe?
Yeah, come on
Can
up.
I try to do my thinking on the board?
Yeah, you can do whatever. You can erase this live text thing.
Okay. So I'm
Do you want me to erase it? I mean, there's erasers.
2, 3, 4, 5. So we know that this is 22 units. And we're trying to get to we're trying to get to 110, right?
Mm-hmm.
So a perimeter of 110. Wait. So I'm trying to get to 110. This is so hard. So I was thinking of like seeing how many 5s get it equal 110. And then once we figure that out, we can add up each of those 5s because we know that 22 units are 5 hexagons. So if we added those all the way up until we got to 110, I feel like that would give us the answer. Does that make sense? I feel like I'm not explaining this very well. You understand what I'm saying? No.
I'm sorry.
Okay, I'm gonna get my calculator.
Okay.
I'm really trying to understand what you're saying, but
I'm trying to understand what I'm saying too. It's okay. Yeah, never mind. I don't know.
Did you abandon ship?
Yeah, I abandoned it because I don't. I don't know what to think about. Your picture kind of brought it back, but I don't remember now.
Okay, so
really good try though. That was good effort, Sierra.
if it if it comes back, let us know, because I think I do definitely want to capture it. I want to go back up to this work where you guys took that equation that was brought up in the student work, and you said, hey, let's use that, which was awesome. So where does 4x plus 2 make sense in this picture? Where's your 4, which is your coefficient to your x? Where is that?
It's the 2 at the top and 2 at the bottom in the middle.
Yeah.
Yeah, so this 4 is literally this. These two, these two, these two, these two, these two, these two. So that's a 4, that's a 4. So where's the plus 2?
It's the 2 sides that are shared.
Yeah, your ends. Isn't that awesome? Like it matches up, it makes sense, we've connected our representations. So when you go back and you think about if the perimeter is 110, then what train number is it? Then you subtract these two, which is what you did, and you got 108. And then you say, okay, it's 4. 4 times some number is going to give me my train number, because that would be how many hexagons I have. And that's what you did. You did it algebraically, but it connects beautifully to the picture. I'm so proud. Y'all did it. You did it right here, but it makes sense. Yeah. Doesn't that make us happy?
Dr. Ivy, you look like you need to do a happy dance. That's what you look like.
I'll wait till after class. All right. So, the last thing that we did that I had planned was to talk about student questions for asking the students. And student A, you guys noticed, had the correct solution. So I want you to think about why not just, that's number 2. Why ask a student who has a correct answer questions when you could be spending that time working with the student who's struggling? So let's start with that question. Why are we still messing with asking student A questions? They got it right.
Because of what Sierra said, enrichment. They need to be challenged further. It's still contributing to the whole learning. Even though they have the right answer, they need to be able to go backwards now and tell you how they got that answer.
Yeah, that student was still missing some explanations, right?
Mm-hmm.
And so being able to communicate about mathematics, that metacognition piece that you guys brought up, is still essential. All right, what about this one? Why do we not just tell them what they should have done? Or say, look at student A. Huh?
Because productive struggle, they're not going to struggle if you just tell the answer.
Yes. Keep going. Let it be their learning. And you've got to meet them where they're at. So it's not about them memorizing how to do the hexagon problem. It's more about developing skills that they can transfer to many different situations. So it's very, very important that we not just give them the answer that we already know. I knew that answer all along, you guys. I know that might be a surprise. But no, I'm kidding. But you guys get more out of it if we can productively struggle about what the solution is. Right? So same thing for your students. What about the types of questions? The types of questions we saw in the video and the types of questions that you came up with. How do the types of questions work as we think about it?
They require the student to think more rather than just saying what is the answer? They clearly know the answer, but how can we get them to think further about that?
I kind of thought of it as picking your brain questions. When someone says, I'm going to pick your brain about this, that's how I kind of thought about the questions. They were questions that they were using to make you think back to what you did and really dissect your process and explain it.
Mm-hmm.
Yeah.
Questions to make your brain hurt.
So, probing questions.
No closed-ended questions.
Yes.
No closed-ended questions. There was no yes or no to that.
How many sides are on it? Or how many? Yes.
Yeah, that wasn't going to work. All right. So good. Any other big ideas? What do y'all think? Did you enjoy the hexagon problem?
I did. I'd like to struggle with it, even though I still don't know what I was thinking, but
You still haven't figured out your thinking with regard to this
I
thing?
haven't.
Okay.
I really don't know.
Well, if it comes back, we're still going to listen.
Even in the middle of the night, FaceTime both Dr. Ivy and I at the same time.
Just send us an email. We'll get it when we
Maybe
wake
I
up.
should just work it out and print it.
Yeah. Yeah, bring it next week.
I only bring it if I get the right answer though. If I get 27, I'm silly, but if not, I'm not silly.
All right, so today we've looked at algebraic thinking, how we can build on students' understandings of number sense, how we can build on their experience with patterns, the relationships between numbers, the structure of the number system. We looked at the properties, how we can use that. And we use the hexagon task as a very specific example of a pattern where students can generalize. And then we connected that all back to what we did on the very first day, and we've sprinkled throughout the semester, which are those 8 effective teaching practices from NCTM. So this was our last big day of, like our last normal class day of content. We have next week as well. Next week's gonna be a wrap up of the semester, and we're gonna prepare for the final exam. Because we know last week is the last day that we get to meet, because the last day is study day. Or the following week, the Thursday is, or Friday is study, the Thursday is study day and the Friday begins finals, I think, actually.
That's intense.
It's intense. It's happened very quickly. All right, so the last bits that we have are some reminders. So next week we're going to talk about final exam expectations. Your field journals, which include 3 prompts and a summary as posted on Moodle, are due, actually they're due next Friday. I don't know why it says Thursday because I was thinking about my Thursday class. So all the instructions are on Moodle. Your lesson plan needs to be submitted to LiveText before you take the final exam. So on LiveText, there are multiple portals because of field class. But there's one portal that says EDUC336, and you'll submit the math lesson for our class there. And then your final exam time, you can select whether you would like to take it. Sierra's already signed up for the 11:30 section, right?
Am I the only one that has?
I think so.
Yeah.
We'll have a good time. You can sign up for the 8:30 section or the 11:30 section. I actually don't mind if anyone wants to come to both. If you think you want double time, come at 8:30 and stay with me all day. I don't think that's necessary. But if you would like to do that, I'm not limiting the time as long as you have the time available. But you can certainly sleep in and come at 11:30, which is the true time for the class. Note that the 2 different times meet in different classrooms by the university schedule. So, I also wanted to show you guys what I posted on Moodle. Did anybody see what I posted on Moodle already?
I've been on your Moodle page, but I don't remember.
Okay. I actually downloaded it earlier.
So Dr. Ivy,
Yes.
so with this math lesson plan, we have to submit it on your class on LiveText and for our field?
If you use the same lesson for field and my class, then you would submit it in both
So
places.
I have to do that for Dr. Miller too?
Yeah.
Since